Hello, everybody. Today we're going to talk about solving special systems of linear equations. So these are the weird ones today, all the exceptions and weird stuff. So, three things can happen when you have a system of linear equations. You can have the two lines intersect like this, and bam, there's the answer. So it has one solution. Now, it cannot have more than one solution because if these are straight lines, there's no way this one can curve back and cross over the line again. So you don't have to worry about a second solution once you get the first one. They can be parallel lines, in which case there's no solutions because they never cross each other. And then they can both be the same line, and then you have infinitely many solutions. Okay, so there's your three choices right there. Either one, none, or infinitely many solutions. Okie doke. So solve the system of linear equations here. So here's the thing. I can graph these. So let's see. Y equals 3x plus 1. Oh, I didn't graph that. Okay, so I need a straight line. Okay, so it's going to look something like this. We'll make this first one blue. Okay, and it's 3x plus 1, so it's going to look like this. Okay, it's going to go through the point 1. It's going to have a slope of 3. Just like that. Okay. Now, we've got 3x minus 3, so let's do this one in red. It's going to go through here. It's also going to have a slope of 3. So it's going to look like this. Well, guess what? If I get that right. Those are parallel lines, my friends. They're never going to cross each other. And you know what? You can short circuit this right away. If they're in slope-intercept form like this, you don't even have to graph them. You can just look at it and go, hey, these two lines are parallel because, hey, they have the same slope, right? If they have the same slope, they're parallel. That implies they are parallel. Ooh, that's terrible English. That implies parallel. Okay, and if they're parallel, that implies no solutions. They are never crossing each other. And so you're done. So I would say, unless it tells you to graph them, if you can look at it like that and say, hey, those are parallel lines, then you're done. Okay? Now, they don't always come out nice like this. I could disguise this so that they're really parallel, and you'd have to do some algebra to put them both in slope-intercept form or something. But you can do that. You can use algebra to put them in slope-intercept form and look at their slopes, or you can graph them whichever way you like to do it. Okay, like this one. This one's not exactly obvious right at the beginning. Okay, so I could graph them. So let's go back and look at this again. So y equals negative 5x minus 2. That's going to go here. It's going to have a slope of negative 5. This is super steep. 1, 2, 3, 4, 5. It'll look like that. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. Yeah, okay. So super steep. Okay, now this one, I could do this with a table real quick. So, that doesn't really work because if I plug in 0, I get y is 0. So 0, 0. So that's going to go through the origin. This is not a good one to graph. Pick another point. How about 2 for x? So then that would be negative 10 for y. So let's do that. 2 for x would be negative 10. That makes 0. So then 2, negative 10 is going to be like right here. So use this purple. So it's going to look like that. They're parallel again. Okay? This would be an easier one than if you just took it and said, you know what, I'm going to subtract 5x from both sides on here. Then it's y equals negative 5x. Now it's in slope-intercept form, and so is that one. You can just look at it and go, hey, the slopes are the same. I'm done. They're parallel. There's no solutions. Okay, so parallel implies no solutions. Okay, a perimeter of rectangle A is 36 units. The perimeter of rectangle B is 108 units. Write and solve a system of linear equations to find the values of x and y. Okay, so perimeter. So rectangle A is going to be 4y plus 2x plus 4y plus 2x is going to equal 36. So I can combine my like terms and I get 8y plus 4x is 36. Okay, now over here I get 12y plus 6x plus 12y plus 6x is going to be 108. So I combine my like terms here and I'm going to get 24y plus 12x is 108. Okay, so, if you look at this, this one's kind of an obvious one. 8 times 3 is 24. 4 times 3 is 12. 36 times 3 is 108. These two things are the same line, okay? So if I were to put these in slope-intercept form, here, we can just do this. If I put them in slope-intercept form, this would be 24y would equal negative 12x plus 108. And then I divide by 24. And I'm going to get y is negative 1/2 x plus 4. No. That's 96 plus 108 divided by 4. Oops. 24. So that's 4. That's 96. Oh, they're not the same one. 2, 12. That's 4.5. Okay. Now so that's the green equation here. Let's make this all green. Okay, then we'll look at the blue one. So we'll take 8y is going to be negative 4x plus 36 divided by 8. Oh, they are going to be the same line. Okay, so y is going to be negative 1/2 x plus 4.5 again. Okay, those are exactly the same line. Okay? They have the same slope, they have the same y-intercept, they're the same lines. Guess what that means? That means, folks, there are infinitely many solutions. Everything's a solution. Anything that works in this equation is going to work in that equation. Okay? So those are your two special cases that you got. So why don't you pause the video here, solve this one, see what you get, and then jump back on and see if you were right. Okay, so we can take this equation, 2x minus 4y is 10. Probably the best way to do these is just put them in slope-intercept form. So I subtract 2x from both sides, divide by negative 4. This is 2.5. Okay? And then I'm going to take the blue one, negative 12x plus 24y is negative 60. let's see, this is going to be a 12x over here, minus 60 divided by 24. Y is going to be 1/2 x minus 2.5. Hey, that's the same line. Okay, so since they're the same line, there are infinitely many solutions. There you go. Okay, so we will get to do 1 through 25 odd in class next time, and I will talk to you guys later.